Hello everybody. I know it's been a minute, but I've joined the Bunderkin game development team, where my primary focus is developing the movement mechanics for this little guy. His name is Beatty. I plan on making a couple of videos talking about some of the things that I've kind of stumbled upon during development, which kind of segues into this video. So we're not using root motion for any of our animations. We needed to find a way to take Beatty and push him somewhere else. We tried so many different things, but nothing really felt right until... Just in case you don't know, animation curves are just float values that you can key inside of your animation sequences. I want to say I'm not 100% sure on this, but I think Unreal primarily uses these things for like changing material parameters or like morph targets. But if you think about it, they're just values that change over time. So if we can find a way to access the output of these curves, then we can do whatever the heck we want, really. Now, yeah, sure, I could acknowledge that it might not be the best thing to do or even the most efficient thing to do, but it works for me, and that's what matters.
It doesn't matter what you think!
Cool. So the first two examples of me using curves for motion is actually in the sidling and the ledge shimmying that Beatty can do. So for these two states, Beatty either has to move along the ledge or push up against the wall and start moving along that wall. So we need something to fake the acceleration and deceleration of his steps. Let's say I want Beatty to gradually move 250 units while sidling. But once you add a curve and have it start at 0 when the character is stationary, then have it ramp up to 1 during the movement phase of the animation, and then at the end of it, you key the curve back down to 0, then you can use things like get curve value to extract that curve data as a float that we can use during animation playback for our code. It gets a little bit more complicated in this next example. As you may have already noticed from the earlier clips in the video, Beatty is able to jump up to ledges, but the issue is that the height range is pretty big. The range of jumpable ledges can range anywhere between 80 centimeters and 200 centimeters. And the goal is to make sure that these movements look natural, or at the very least, smooth. So to start, I'll explain how we broke it down into 3 different categories. Anything below 80 centimeters, but still higher than Beatty's maximum step height, is considered a skip up height. So Beatty will just jump up and move on with his life. And this is very easy to do with the gameplay ability system because we can just use the apply root motion jump force node, and that pretty much takes care of it. Then we have the 80 to 160 centimeter range. This is considered a hoistable ledge and is the one that requires the most work and the curve logic that we're about to talk about. And just to fill in the last category, anything above 160 to 200 centimeters is a completely different kind of thing. It's what we would call a jumpable ledge, and it's a completely different state change with extra bits of logic. So we started by exporting out 2 separate base animations. The first one is called the 80 centimeter hoist, and the second one is a 130 centimeter hoist. The original range was supposed to be 80 to 130, but because it just didn't feel right, we rose it up to 160 instead. Anyways, we intentionally made the base animations the same length so that it was easier to go in and adjust the curve in one and then copy pasta over to the other one and done. Okay, cool. We have 2 separate animations, but how do we go about selecting the right one for the job? The key was math. So once you do the math to get the ledge height, you can pretty quickly figure out if what Beatty is about to climb is above 80 centimeters. If so, we just use the 80 centimeter base animation. And if the ledge height is actually above some arbitrary number, say 100 centimeters, then we can just force it to use the 130 centimeter base animation instead. And this very same logic is actually extremely fundamental in how we actually figure out the offset. So just really quickly, if we're climbing a 90 centimeter ledge, and we subtract 80 centimeters from it, we find that the offset we need to apply is just 10 centimeters. Hooray! I'm gonna show you guys how to set this up in your animation sequence real quick. First thing you need is the animation itself. Ta-da! We create a curve here. Keyframe it at 0 right before the jump starts. Then we can key it at 1 once Beatty reaches the top of his animation. Nice. Back in the animation blueprint, this right here is where I'm switching between the 80 centimeter base animation or the 130 centimeter base animation. Here is the actual ledge height minus the base animation height. Then we read the curve value during animation playback, multiply it by the offset, and then apply that offset to the cog mode. The cog bone is just the center of gravity bone in BD's skeleton. That's not really important. What is important though is using the transform modify bone node in the animation blueprint. Once you have one of those, you just need to set the translation mode to add to existing and does translation space to world space. And look at that. Oh yeah, and there's still one more thing. The problem is that while the animation itself is moving the mesh up to the ledge that needs to climb, the actual component is still at the base of the ledge because it hasn't even started moving yet. So to just keep things simple, we'll just boop. Nobody's gonna know anyways. It's not perfect, and again, like I said, very hacky, but it works for me. So I'll live with it. And with that, I'm done here. Thank you guys so much for watching, and keep in mind that all of this footage is extremely not final. We're preparing for the demo later in spring, so keep that in mind. Later!